All right, my friends, recording this in the event that I can't make it on Thursday, May 20th, although I have a feeling I'll be there, but doing this just in case. Kirchhoff's laws. You can pause this and write stuff down. You can pause this and write it down. Do know that for tests, you'll be given these, like V series is V1 plus V2 plus V3, V parallel equals V1 equals V2 equal, and so on. You'll get these. There's 4 more to come. You'll get those on the test. Good, got it all written down? Lovely. Pause it so you can write that down. You'll get these. Notice they switched. Series is equal for current, parallel is adding. For the voltage, series adds up, parallel is equivalent. You'll see what this means once we get to a diagram. Maybe you can see this little diagram I got in my little mini window here. This is a good chapter. Well, let's just get through the notes. To write that down, pause it, because I'm not waiting super long. All right, table 1, yeah, it's good to know. You don't need to memorize it, but it is good to know. It says read through tutorial 1. That's a good idea. There's lots of steps, especially if you don't understand the examples that I'm going to do. This is a decent chapter to read through. They all are. Like, it's a good idea to read through them all, but you should read through this one too. All right, I'm going to do the example from page 522. So first of all, I've summarized here's the equations. Series voltage, you add, series in parallel, voltage and parallel are equal. Notice they flip here. Parallel current, series equals parallel, you add them up. All right, you don't have to memorize it, but it's good to be comfortable with it. So question on page, I should get a different color pen. This is page 522. You may wish to refer to the book just to see what it's supposed to look like while I grab another pen. All right, so the first question, it tells you that the voltage at the source is 60. So we'll say V is blue. The voltage at the source is 60, so let's put that there, 60. At V1 is 20. V3 is 15. So we have to get all the other ones from that. Now remember that in series, this is series. These two are in series. These 3 are parallel to each other. Okay, these 3 are parallel to each other. These are in series. It's kind of like saying they're in a row. This one is kind of considered the in series as well, but as a group. Okay, you'll see how that works in a second. The easiest ones are the ones that are all equivalent. So when they're parallel, they're equivalent. So this 15, that means this one's 15. That means this one's 15 because they are parallel. Now 20 plus something plus 15. This is how I was saying it's kind of taken to be 1. 20 plus something plus 15 equals 60. Or 60 minus 20 is 40. 40 minus 15 is 25. So V2 is 25. What were we given V3? V4 is 15 and V5 is 15. All volts. Cool, cool, cool. I'm pretty sure I'll be here to go over this with you guys anyway. So that's in blue. Now let's bump it up to current. Let's do current in green. So I'm going to label first I1 is 0.7 amps. I3 is 0.1 and 0.5, or I5 is 0.2. So notice in parallel, they don't equal. They equal in series. And that includes the source. So the source, 0.7. I2, 0.7. What does 0.1, what does this have to equal such that 0.1 plus 0.2 plus this equals 0.7? Remember, as a unit, you can kind of consider it in series. This would be 0.4, right? Because it's 0.6, 0.7, 0.7, 0.7, 0.7. These are all in amps. These are all in volts. Hopefully that makes sense. These are fun. I like this stuff. It's kind of, especially when we get to the end with the resistance, and it's kind of troubleshooting. I like logic problems. 1, 2, 3, 4. We have 4 more lessons. 2 next week. Who knows what'll happen after. Anyway, that's it. This is going to be weird tomorrow if I'm watching this with you. Okay, bye.